If you're a data curator working with Microsoft Purview, you may have noticed some of your assets being marked as belonging to a resource set. In this video, we're going to look at what resource sets are, how they work, and when you might need to use advanced resource sets. We've got a lot of ground to cover, so let's get started. Hi, I'm Brian Hitney, a cloud solution architect focused on data and analytics. Resource sets in Microsoft Purview allow for partitioned data in a file store to be represented as a single entity. When we store data in a file store, like in Azure Data Lake, it's common for us to spread that data across multiple files and in multiple folders. In the data catalog, it's ideal to see this represented as a single entity. So we can think of resource sets like a physical set of encyclopedias. Articles are organized into volumes for practicality, and all of the volumes collectively make up the set. And resource sets act the same way for our data. If we need more control over this process, we can leverage advanced resource sets to specify custom patterns. So for our demos, we're going to use the Purview Lab, which is available at aka.ms/Purview Lab, because it's easy to set up and will allow for anybody to try these examples too. There are several components that are deployed through the lab setup template, most notably in Azure SQL Database, in Azure Data Lake, and also in Azure Data Factory. Module 2 walks through deploying some test data, specifically the Bing coronavirus dataset, to a Data Lake account. More information on this dataset is available in this repo, but in short, the dataset contains popular search terms related to COVID-19 broken down by country and US state, along with query text and a few other fields. We can see that data in the portal by using the built-in Storage Explorer. So in our Data Lake account, if we click on Storage Browser, we could see that we have the Bing coronavirus query set folder. We can dive into that folder. We'll see two different years for the data set. And within each, we'll see queries by country and also queries by state files. For both queries by country and queries by state, there's one file for each month of data. So for example, queries by country, this first file runs from 2020-0101 to 2020-0131, so the month of January, and we'll see a corresponding file for queries by state as well. So there are a couple of things to notice about the way this data is laid out. First, we have two distinct data sets, the queries by country and queries by state. The files are in the same folder belonging to the current year, and the file name denotes the specific month of the data. And now we know what the data lake looks like. Let's see how this is represented in Microsoft Purview. So in our Purview account, I have already set up a scan to scan this data lake, and we'll see that we have two entities here, queries by state and queries by country. The first thing to notice is that these are listed as a resource set instead of individual files. The scanning engine determined these files belong to a resource set because of the pattern detected during the scan. So in curly braces, we could see placeholders for values like the year folder and elements of the date in the file name. Purview will use the static portion of the file name as the entity name. So in this case, queries by state or queries by country, because everything else is a dynamic value. We can then open the details to look at the schema and other properties. So if we click queries by state, we can look at the schema, see the schema associated with the file. So as you may have guessed, resource sets are specific to file-based storage. So that means Azure Blob Storage, ADLS, Azure Files, or AWS S3. When Microsoft Purview scans one of these sources, the scanner applies rules to determine if the file is part of a set by recognizing common data storage patterns. The scanner will recognize patterns like GUIDs, numbers, dates, localization codes, Spark partition identifiers, and dates within the file path itself. So this is a good time to take a quick diversion and talk about scanning. You may have seen references to L1, L2, and L3 scanning, and this is what that means. An L1 scan extracts basic information and metadata like the file name, the size, and the fully qualified name. An L2 scan goes a little bit deeper and extracts schema for structured file types and database tables. An L3 scan or deep scan is going to do all of that, but also subject the file or database table to system and custom classification rules by examining the actual data. And so while we're not diving deeply into classification here, scanning involves classification and resource sets are going to affect that behavior. For structured file types, the classification engine will sample the top 128 rows in each column or the first 1 megabyte, whichever is less. And that applies to files like CSV, TSV, Parquet Avro, or JSON, etc. For document file formats like doc, docx, the top 20 megabytes of each file is scanned. If it's greater than 20 megabytes, the document is not subject to a deep scan. For tabular data sources, the top 128 rows, and similarly for Cosmos DB. Now, if a file is part of a resource set, the engine will restrict how many files are scanned, as it shouldn't be necessary to deep scan every file, as that only increases the scan time and ultimately the costs. If a file is part of a resource set for delimited files like CSV, SSV, TSV, only 1 in every 100 files are sampled. For data lake formats like Parquet or Avro, only 1 file will be scanned, and I appreciate the call out to the unsigned 64-bit int max value there. For other structured files like JSON or text files, 1 in 100 are sampled, and for document file types like docx, pptx, each file is going to be L3 scanned, as resource sets patterns do not apply to these file types. Okay, that was a lot of info, but hopefully clarifies how resource sets work and how scanning influences that. What are some potential issues or concerns we might run into with resource sets? Well, one, incorrectly marking an asset as being part of a resource set, putting an asset into the wrong resource set, or incorrectly marking an asset as not being in a resource set. Or finally, it could be that we just want more information on partition sizes and the number of files. So to address the first 3, we could modify whatever process is loading that data into the data lake so that it would be correctly identified by the scanner. But assuming we can't do that, we can leverage advanced resource sets to have finer control over the way resources are identified. So to see this in action, we're going to manufacture some data that is, shall we say, less than ideal in order to see how we can mitigate that using advanced resource set. So to keep this fast and simple, we're going to work with the tools we already have in our lab, which include an Azure Data Factory. And so we'll switch over here to this Azure Data Factory account, and we'll extract the customer data from the existing AdventureWorks database. We'll start by opening the Azure Data Factory created in the lab. We can see that here in the list of resources belonging to the lab's resource group. From this page, we can click the link to open Azure Data Factory Studio, which I already happen to have open in another tab, so I'll switch to it. This isn't intended to be a tutorial on Azure Data Factory, but rather an example of how you can use it in this instance. We'll have some references in the description if you'd like to learn more about how to use ADF. We'll start by creating a new pipeline, and we'll add a data flow activity. We'll configure this to run a new data flow that we'll create. And we'll turn on debug right away to spin up a debug cluster so it's ready to go when we're done creating our data flow. And also we won't have to deploy the pipeline, as this is intended to be throwaway, so we could just debug this, make sure we're getting our output files, and then we can delete it. So the first thing we'll do, we'll connect to our data source, which is our Azure SQL database. And we'll grab the customer table. We can look at a data preview. We could see all the fields that we would expect in a customer table: first name, middle initial, last name, address. And what we'll want to do is export everything into multiple files in the data lake. So one way we could do this is just by using the first letter of the last name. So an easy way to do this is to create a derived column. We can have this output stream name remain the same. Incoming is source 1, and as a column name, we will just call this the last name group. As an expression, we can open up the expression builder if we'd like to, but this is a pretty simple expression. We'll just grab the left one character of the last name column. Next, we'll add our sync. And there are a few different ways we could do this. Well, here our data set, we'll make sure we create a new data set first by pointing it to our data lake, and we'll just use a delimited text format and select our path, which will just be this customer folder that exists under the extract folder in our root, and select OK. Now for settings, we have a few file name options we can do. We could set a pattern, we can partition the folder if we'd like to here. In this case, what we'll do is we'll just give a file name pattern like customer extract -n.csv, where n is the placeholder for the partition number. Now to actually partition this, we'll click on Optimize and set the partition option using a key. We'll use the column that we created, the derived column, as the key, which is the last name group that we created. So this will only have a single character in it. So in theory, we should have up to 26 folders. And what we could do is go back to our pipeline and debug, and we should get that output right away. Okay, it succeeded, and if we go to our data lake and hit refresh, you could see that we have last name group corresponding with each letter. Obviously, if a letter is missing, it means there were no customers with the last name with that letter. And within each one should be customer extract. And we only have one file for each group, but in theory, we could have multiple ones if we broke it down further. But remember, our intent here was to purposely create some suboptimal data storage. And so I think we accomplished that pretty well. So next what we'll do is we will go back to our Purview account and we'll add a scan in order to pick up that new data. In this case, we'll limit the scan to our extract folder. As you can see, it has the customer and should have all of the subfolders within it. We'll click continue. We're going to run this scan only once. Save and run. Now this scan is going to take a few minutes to run, so once it's done, we'll come back and look at the data in the data catalog. Our scan is finished, so let's look at our data catalog and see what happened. Well, we could see that it found all of the files and it even recognizes them as resource sets, but it isn't grouping them at the folder level. So we'll have a different resource set for every letter. So to fix this, we can enable advanced resource sets and specify a custom pattern. To do that, we'll go to Management and enable advanced resource sets. And we'll have to turn this on explicitly because there's an additional charge for using advanced resource sets. And you can refer to the current pricing for more details on that. Once enabled, we can go back to our data map and we'll see that pattern rules under source management is now enabled. Here we can specify a custom pattern to scan our customer list. Now, patterns work as you might expect. We can specify a custom pattern using values like strings, integers, GUIDs, dates, times, and so on. Once we know what we would like to replace, we can specify the path in the pattern rules. So before we do that, the first thing to note is that there are two kinds of replacers, dynamic and static. Dynamic are values that represent replacements that apply to the entire resource set. So for example, our last name group folder with A and B and so on, those are all dynamic because they should all belong to the same resource set. If we were collecting data from IoT devices and we wanted a separate resource set for each machine name, we could specify a static replacer for the machine name and use dynamic replacers for the rest. That would mean that every machine name would then get its own resource set. So let's set up our new pattern rule. We'll click New. And for account type, we'll select our ADLS Gen 2 account, select our storage account. And for folder path, we'll need to provide the path that we'd like to constrain this pattern to, in which case we are going to constrain this to extract/customer. And then we'll create a configuration rule. For the rule name, we'll just give it a friendly name that we can refer to, which we'll just call the last name group. And for qualified name, we'll need to provide the pattern that will match our data. In this case, last name group equals with a string replacer for the folder. So this will match last name group equals A, last name group equals B, and so on. We'll use a dynamic replacer represented by the single curly brace, /customer extract dash, and then the number for the partition number. And finally, a display name, which specifies the name the resource set will have in the data catalog. We'll use customers. We can optionally force everything that matches this pattern to not be grouped as a resource set by checking this box. We won't do that in this case, and then we'll create the rule and click OK. Next, we just need to rerun our scan. In our data map, we'll go back to our storage. We can see our scan, and we'll rerun a full scan. This will take a little bit of time to run. With the scan done, we'll be able to find the customers in the data catalog. Notice that the resource set pattern matches the pattern we specified in pattern rules when we configured the advanced resource sets. We may still see some of the entries here from the previous scan. However, advanced resource sets will clean those up typically within a few hours. I've allowed a few hours to pass, and we can see that the catalog has been updated. Because my tenant is configured with Microsoft Purview information protection, a confidential sensitivity label has been automatically applied to the entity because of the customer information contained in the files. We can also go into the customer's resource set and examine the properties. This has been enriched by advanced resource sets with properties like sample URI, partition count, and total size of the set. So that's an overview of resource sets and advanced resource sets. The key takeaways: resource sets apply only to file storage types and will often work just right out of the box. If we need additional functionality, we can use advanced resource sets, but that will have an additional cost. In the description below, I'm going to include a number of resources with more examples and documentation. And as always, if you have any questions or comments, be sure to let us know.